Welcome back, THS chemistry students. Today we're talking about classification of matter. What you're going to do today is on your sheet, you're going to write down the definitions of certain words that we've listed for you. That's going to be on this video. You're going to get those definitions down, and on the back we're going to make a flow chart for the classification of matter. So let's get going. Okay, defining matter. What is matter? Anything that has mass and volume is matter. So everything around you, from what you can touch, from what you can bump into, all your interactions with the things around you, that is matter. Okay, matter is made up of interacting subatomic particles. All atoms are made up of subatomic particles. You may have heard of these before. They're made of a nucleus, which has protons and neutrons, and they have orbiting electrons. So matter is the interaction with all these protons, neutrons, and electrons. All right, so the definition you're going to get down for matter will be anything that has mass and volume. All right, there's two types of matter. Okay, they're broken down into pure substances and mixtures. Okay, what a pure substance is anything that has a definite or fixed composition. It cannot be separated into simpler substances by physical methods. Okay. Mixtures, on the other hand, are made up of two or more different substances which are mixed but not chemically combined. Okay, so right now you want to put those two things on your notebook or on your sheet. All right. If you need to pause it, write them down. I'll give you a second here to catch up. But you're better off just pausing the video and we'll continue. Okay, first we're going to look at the two types of pure substances, which are elements and compounds. All right, elements are the simplest form of matter. They're made up of atoms, cannot be separated by physical or chemical means. Okay, physical means by separation would be filtering or boiling. Chemical means is where you separate the elements into something simpler, like NaCl is separating to Na, sodium, and Cl, chlorine. Sodium and chlorine are elements. NaCl is a compound. All right, a few examples of elements would be carbon. Okay, diamond is carbon. That's why I put a picture up there for you. Iron is an element that's found in the ground. Okay, there's a lot of metals that are elements. All right, compounds, chemical composition of two or more elements. Examples: water, H2O, sodium chloride, NaCl. All right, these are pure substances that cannot be separated by physical means. You can't filter NaCl. Okay, you can't boil off water. You're still going to have, when you do so, you can boil off water, but when you do so, you're still going to have H2O. You can't separate the H and the O by physical means. You have to separate them by chemical means. All right, so the pure substances are elements and compounds. So, get both of those definitions down in your notebooks. You can put the examples down if you want. All right, the two types of mixtures. Okay, the first one is homologous or homogeneous. These include solutions. All solutions are homologous. They have the same composition throughout the sample. Okay. Example would be air. You can't see all the elements in the air. You only see one thing, or you can't even see air most of the time. But it's a mixture of many different things. Salt water. Okay. The picture on the left is salt water. You cannot see the salt, but the salt is dissolved in the water. So there's two things that are mixed together, but you only see one thing. That's the same composition throughout. Okay, if you only can see one thing and there's more than one thing in there, that's a homogeneous solution, or a homogeneous mixture or a homologous mixture. Okay, a heterogeneous is when the parts of the mixture are visible. The composition is not the same throughout the mixture. Okay, example would be sand. There's many different rocks and coarse materials that are found in sand, mostly silicon dioxide, but there's many different things that are in sand. Food is great examples of heterogeneous mixtures. Okay, chicken soup, you can see the carrots, chicken, the noodles. Chocolate chip cookies, you can see the chocolate chips in the mixture. Okay, those are heterogeneous mixtures. Anytime you can see the parts. Okay, so get your definitions down. Again, you can put the examples down if you want. It helps you out. Okay, when you got these down, you're going to flip over to the back. And we're going to do a little flow chart here. Again, you can pause this video at any time. Right? Write down the definitions. All right, this is what you're going to do. You're going to make a flow chart in the back of the paper. Okay, start with matter. Matter breaks down into pure substances and mixtures. So make one go to the left, one go to the right. Okay, elements and compounds are part of pure substances. So make a flow chart going to the elements and compounds. And then heterogeneous and homogeneous off mixtures. Okay. All right, this is another flow chart. Kind of helps you see what is what here. If you have matter, can it be physically separated? Okay, mixtures can be physically separated. Pure substances cannot. All right, so if you have something that can be physically separated, you have a mixture. All right, and then is your mixture composition uniform? That means, is it the same throughout? If it is, all right, you probably have a solution or a homogeneous mixture. Okay, if you have a pure substance, that means it cannot be physically separated, and if it cannot be chemically broken down, it's an element. Okay, this is another way the flow chart can flow. Okay, again, so matter can be broken down into pure substances and mixtures. All right, mixtures are when you can have composition of two or more things. All right, it could be an element, it could be a compound mixed together, it could be two elements, it could be two compounds. There's no certain definite composition for a mixture. Pure substances, on the other hand, are always one thing. It's always made up of the same element, or it's always made up of the same compound. All right, they're pure. All right, thanks for checking in. We'll see you soon.